Welcome to NC Math 1. My name is Dr. Howard, and our lesson today is solving simple equations. We're going to use 4 of the properties of equality that was discussed in our class. Let's solve several equations using these 4 properties, and I will demonstrate. For example, on the board, the whiteboard that I have, I'm going to say x minus 3 equals to negative 5. Okay? Now, when we look at x minus 3 equals to negative 5, look at the variable. This is the variable. Alright? Now, according to our our graphic organizer for solving simple equations, I recommend looking at your neighbor. So I'm calling the variable x right here. The neighbor is negative 3. Okay, that's the neighbor. Now, if you have a neighbor, either it's a negative 3 or positive 3, let's use one of the properties for equality. So when we look at the operator, whether it's a minus or plus, we want to pick the operator and decide which property that will give us the opposite of what the operator is stated. In this case, if you have minus, then we would use the addition property of equality. So in this equation, I will add 3 on both sides. All right, so that will be a balance. When you add 3 on this side, for the balance, you add it on the other side. So it's equal. So it's an equal balance. A minus and a plus will cancel. Okay? Bring down the x. X equals to. And then we have unlike signs. A negative 5 and a plus 3. If you look at the 5 and a 3, you have more negatives than you have with positives. That means that there's going to be a difference, and the difference will be the sign that has the most quantities. In this case, negative will be the leftover, and the quantity will be 2. So x equals to negative 2. And I use the addition property. All right. Okay, here's another one. All right. 9/10, we're going to use a decimal, equals to y plus 2 8/10. All right. Now, you have an opposite sign this time. You have the plus, the addition. So we're adding. In the last problem, we were subtracting. We had the subtraction problem, x minus 3, and we used the addition property to cancel out. Likewise, look at your operator, and you have plus. So we want to pick the property of equality that will offer the opposite, which is the subtraction property. All right, using the subtraction property, all right, we're going to subtract 2 8/10 on both sides. And draw my line. And this is the standard method, method 2, which is the straight line horizontal method. All right. And notice your plus and your minus, they cancel. All right. We bring down y. And it doesn't matter whether y is on the left side or on the right side with the equal sign, as long as y or any variable is by itself when you're equating. Equals to, and then you take the difference of this. And again, you have more negatives than you do positive. If you don't see a sign next to the number that is in front, it's understood to be positive. So we take the difference, it's going to be negative 1.9 or negative 1 9/10. Excuse me. All right. So we look at the subtraction property. We look at the addition property. All right. 2 more properties we're going to look at. All right. Okay. We're going to look at this example. Negative n over 5. Okay. Equals to a negative 3. And also, let me give you some. All right. You can see that. All right, we're going to do another one. Next to that, we're going to have pi times x equals to negative 2 pi. Now I want to illustrate these two types of problems. And I'm going to identify the properties for each one. But you have multiplication and division property, and I'll show you which one's easier to apply. Now, look at this problem on the left side right here. You have negative n over 5. And this is in the form of a fraction, which is a rational number. But regardless, to solve for n, we want the n to be by itself. And how do we get n to be by itself, since n is part of the denominator of this rational number? So when we have types of problems where the variable is in the denominator portion of the fraction, I recommend using the multiplication property. Use multiplication property. All right. Okay, when we do that, using a property, we're going to use what number that we can multiply to get rid of the fraction part of n, negative n, divided by 5. And once we use that property and find a number to apply it to this fraction, we have to do it on both sides of the equal sign. In this case, we're going to multiply a positive 5, the same sign number. So we're going to multiply 5 times negative n over 5 equals to, and then we have the negative 3 times 5. Like all equations, anytime we use the properties, we have to balance the equations. If I use the properties on one side, I have to apply the same method on this right side of the equation where the equal sign is. All right, and notice they cancel. All right, so you have negative n equals to negative 15, but we're not finished yet. In solving an equation, the variable must be positive. And how do we get rid of the negative? Again, we're going to use the multiplication property again, but this time we're going to multiply by a negative 1. Why do we multiply by a negative 1? If there's not a number in front of the variable, it's understood to be 1. In this case, it's negative 1. So we're going to divide negative 1, all right, negative 15 over negative 1. So n equals to a positive 15. All right. Now, what's the difference? All right, look at this. All right. When we get down to here, why didn't I divide? All right. Wonderful question. When we have a rational number, all right, and we want to get rid of the number that is part of the variable that is in the denominator, let's multiply by a whole number. We multiply by a whole number. Multiply by a whole. All right, number. So we multiply by a whole number, okay, to cancel out the 5, all right? And when we did that, we multiplied by 5. This cancels out the 5. And we multiply by the same 5, which is the same positive number on the right side. So it's negative 3 times 5. Then we have negative n. Now look, this is understood to be a negative 1. All right? Negative 1. It's understood to be a negative 1. If there's not a number in front of a variable, it's understood to be 1. In this case, you had negative n, which would be the negative 1 portion of the variable. So we divide by negative 1. So we use the division property here. All right? So we use the division property here to cancel out your negatives on both sides. So when you have a whole number of n or any number in front of the variable, when you at the last step in dividing, you use the division property, and that will cancel out your constant that's in front of the variable. Let me demonstrate another one, because this one was like a two-step equation process. Let's use a formula. Okay, so we have pi times x equals to -2 pi. All right, pi times x equals to -2 pi. Now, how do we solve for x? We have to get x by itself. Since pi, now you don't see a fraction, right? All right, you don't see a fraction. We don't have to apply the multiplication property when we have whole number on both sides. You have a whole number in front of the x. All right, so we don't have to use the multiplication property. We can use the division property. Use division property, all right, when dividing whole numbers. That's if the whole number is in front of the variable, like so. Pi x equals to -2 pi. Divide by pi on both sides. All right. Notice I use the same sign. It's all positive. So in multiplication and division, use the same signs when you perform the operations. But notice when you use addition and subtraction, opposite signs. Opposite signs. Plus, minus. Minus, plus. All right. Let's go back to the next. Back to the problem. All right, so they cancel. The pi's cancel. All right, so you bring this down. X equals to -2. All right, that's your final answer. And notice x is positive, so that is fitting the correct syntax for all equations. All variables must be positive. All right, if not, you have to divide by -1. I hope you enjoyed this video. We've discussed 4 different types of problems illustrating each of the properties of equations. All right, thank you again, and you have a great day. And this is Dr. Howard.